In lecture 21, we will be continuing the selection topic or the decision making topic while we are constructing programs which depend on, or their execution depends on taking some kind of a decision. We will be looking at the else if construct, which emphasizes the parallel nature of the logic. We will be looking at the switch statement, which is another way to write the parallel nature of the logic. And then we will be using the break statement, which is really important in the switch expression in the switch statement, to avoid the fall through, which is an error. Then we'll be making some few programs such as a calculator and range of scores and maybe a report card. And then finally we'll be looking at the conditional expression operator, which is actually a ternary operator, which is really simple, that we write a condition. If this condition is true, then this whole this whole thing returns expression 1, or if this condition is false, then this expression is returned. Nested if-else statements are used to test a sequence of parallel choices or parallel alternatives, where only the else clause contains further nesting, which only runs whenever the most recent or the coupled if statement condition is false. In that case, the resulting compound statement is usually formatted by lining up or writing the else if phrases to emphasize the parallel nature of logic. Let's take a look at an example. I've written the codes everywhere here in this whole lecture, so I'm just going to explain how these codes actually work. So this is using a else if construct for parallel alternatives. Essentially if else and if else kind of a thing. I could have written if else and then so on and so forth. It's asks the user for a character, and it says welcome in the language in which the user has selected. For example, I write a character language. So character is the name of the variable which stores some kind of a character, and then I see out English, French, German, Italian, Russian. I give the user choices: E for English, F for French, G for German, I for Italian, and R for Russian. And then I take the input from the user, whatever character the user has typed on the keyboard, and then assign it to the variable language. Then I see out just to go to the next line, and then I check if that variable, whatever the user has entered on the keyboard, is equal to E. Then I see out welcome. That means the user has selected English, and you can just write any message over here, and then I check else. Else will only run if this condition is false. So then I will check, okay, if this condition is false, then check whether a language is equal to which I write. It's not an assignment operator. We are just checking for the equality here. We are going to check whether language, which is a character variable, contains a character which is equal to F. Then we will see out bonjour. Then if this thing is not true, then we go to this else, because this else is matched with this if. So if this condition is false, then we go to this else, and we'll check whether this language is the variable contains G, and if it's true, then we see out gooding tag. And then if this condition is false, then we go to this else, and when you check whether the language is equal to the variable is equal to I, then we see out this Italian phrase, whatever that pronunciation is. And then if this condition is also false, then we go to this else, and if this, we check for this condition, and then we say welcome in Russian. And if this condition is false, then we say see out sorry, we don't speak your language. So this else, these are essentially the using essentially the if-else nested statements to select from the 5 given alternatives. An ordinary nested if-else statement, the code could also be formatted as like this. So this if is coupled with this else, and this if is coupled with this else, and this else is coupled with this if, and this else is coupled with this this else is coupled with this if, and this one is coupled with this. So this you can write in this format as well, or you can write this in this format, because it emphasizes the parallel nature of the logic much more clearly, and it requires less tab character or indenting. So in the last I could have written like that, so no problem at all. I could have written like something like this. So if which in Urdu we say that अगर ये चीज़ true नहीं है तो फिर ये run करो, which in English, sorry for that, which in English we say if this thing is not true, then go here, and if this thing is not true, then go here, and if this thing is not true, then go here, and then if this thing is not true, then go here, and if this thing is not true, then go here. So let's try running this code once, and it's going to ask let's say I press for example F, and it says welcome in French. So if I remove these else statement, what would happen? So if I remove this else statement, then it can work, but what about this last thing? It will be this else would be coupled with this else, and if this thing is let's say if I write any other letter except for E, F, G and I, R, I press for example U, so then it will say sorry, we don't speak your language. So let's try running this statement, and let's see what we get over here. If I say E, it says welcome, sorry, we don't speak your language. So what actually happened is that we press E over here, then E is equal to E. So this expression, this boolean expression actually returned 1, which is true. So if the condition became true, then cout is welcome. Then it checked for E is not equals to F, okay, so it did not run, and E is not equal to G, so this condition is false, so this thing actually not ran, and E is not equal to I, this condition is not true, so this condition, this cout did not run, and E is not equal to R, so obviously this condition is false, so then cout of this Russian did not run, and else actually ran. So else is else will only run if this condition is false. So it's not the parallel alternatives here. So to write this thing, if you want to write that if the user has entered a character which is none of these characters, so we need to write an expression something like this. It's kind of a convoluted expression. I'm going to explain that. I'm going to write if over here. I'm going to copy it, if and I'm going to delete this else, and first I need to run the code here. So let's run this code, and if I press U, it's not in the given choices, and it says sorry, we don't speak your language, which is correct. Had I pressed any other letter except for I pressed E, F, G, I or R, it would have printed the correct message. Now how this thing actually work is I'm not using the else if constructs or if else constructs. I'm not even using the parallel logic over here. I'm just saying that if language, whatever the character user has entered, is not equal to E, and let's say U is not equal to E, so that means this condition is true, and U is not equal to F, this condition is also true, and U is not equal to G, and U is not equal to I, and U is not equal to R. Then if all of these conditions are true, that means the user has entered a character which is not in the given choices. So we just cout sorry, we don't speak your language. It depends on your personal choice. I think writing this really long statement is also okay if you understand the logic. Otherwise, the original else if construct was much simple to write whenever we are writing about the parallel alternatives, or we are writing parallel alternatives in our program. Another example is this program converts test score into some letter grade. If this the score entered by the user is more than 100, it says this is out of range. If it's more than or equal to 90, it says it's an A. If it's more than equal to 80 but obviously less than 90, so it says your grade is B. So how this works is that if the user entered a number, for example he or she enters for 81 here, so what happens is that here 81 is greater than 100, this condition is false, else, and now it goes to this else. 81 is greater than or equal to 90, this thing is false, else 81 is greater than or equal to 80, yes, this is true, so this thing is true, and it prints your grade is B. And then since this condition is true, so this else and all the cascaded else which were essentially indented over here, this thing did not run, obviously this thing did not run, and this thing and all of this else statement simply did not work, because they are essentially the cascaded or the nested if else statement. So if this condition were false, then we would go to this else and we will check for this thing. If this condition is false, then we go to this else and then we will check for this thing. If this condition is false, then we check for this else, go for this else and check for this thing, and then if condition is also false, then we say that that score is out of range. But if this condition is true, if I write 81 over here, so these else simply do not run, because instead of writing this thing, I could say that this else looks like this. So I could just indent it over here, and I would say that this else else has the kind of a nested block actually, and this if statement is nested within this else statement, and this if statement is nested within the this else statement. So let's run this thing. So enter your test score. If I write 81, it says your score is B. Let's run this code again, and it says for example, if I write 25, it says your grade is an F. And if I write, for example, 102, it says your score is out of range. And if I write, for example, some weird looking score minus 35, it says that score is also out of range. And this statement is actually over here, because I mean it checked for this thing, it was false, and it came over here and then said this score is out of range. Usually we avoid so much indentation just to make the code easier to write, so we just write it as it were, else, and I'm going to write else, and else, and if you can see it also has the indentation lines, and it says else over here. Much more simple to write. Now I mean this variable score is tested through the series of selection statements continuing until the either one of the conditions is found to be true or the last else is reached. The next topic of this lecture is the switch statement. This switch statement, that is the syntax of this switch statement over here. I mean I've commented the whole lines over here. Going to explain that in examples, lots of examples of switch statement. So coming back to here, this switch statement can be used instead of the else if construct to implement a sequence of parallel alternatives. Syntax is given right over here, and this evaluates the this evaluates this expression and then looks for the value among the case constants. If the value is found among the constants which are listed over here, then the statements in the corresponding statement list, you can have multiple statements over here, are executed. Otherwise, if there is a default, I mean not necessary to give default, but if there is a default statement, then which is actually optional, then the program branches to the if there is a default, then the program branches to its whatever the statement list is giving right next to the default. The expression here must evaluate to some whole number or the integral type, and the constants here must be some integral constants. However, you can also give the range of numbers, but I'm going to discuss that when we see that example in here. I mean I can explain that if you can see, but I'm going to explain that after running through the example number 3, because this range option is only available in the GNU-C compiler which I'm using right now. It's not a standard C or C++ feature, so I'm going to explain that in a moment. So let's go to this example. It uses a switch statement to select a range of scores. I'm going to take the score from the user. I'm going to divide it by 10. So I'm going to say that if the user has pressed, for example, 100, for example, so 100 divided by, let's take an example of first. Let's say user has pressed, for example, 95. So 95 divided by 10, so 95 is an integer and 10 is an integer. 95 divided by 10 would be 9. So it will go to case number 9 and it will say your grade is A, and then it will break. That is important. It will break this whole switch block. The control will exit. After this break, control will exit and control of the program will go over here. That is extremely important. Then let's say the score entered by the user in the next iteration of the program, or the program ran again, was, for example, 82. So 82 divided by 10 is 8 in integer, and this statement, or whatever statement we have given over here, will run. This statement list will run, and then it will break the whole switch statement. If you do not break it, it will have some problems. I'm going to discuss that in a few minutes. Then it will check for cout of, whether if the score is like 70 to maybe 79. 70 to 79 divided by 10 is actually 7. Whatever number you put, either you put 73 or 74 or 75, the integer division will yield 7, and then it will say your grade is C, and same thing goes for 60 to 69 over here. Then let's say if the user has entered the value 100, so 100 divided by 100 would be 10. So then we do not have the we do not have a statement list over here, so it will go or fall through the next C out or the next case over here. It will, since this condition is also already true, this condition is already true, but we do not have a statement right next to it. So what will happen is it will run the very next statement until it finds a break here. So it will run this C out and it will just break. Now if the user has entered a score of, for example, 52, so 52 divided by 10 is 5, but there is no statement. It will try to run this thing, nothing, and then it will say your grade is an F over here, and then it will find the break over here, and this break or whatever break is encountered along the way, because it's a parallel nature of the listed alternatives, whatever break is encountered along the way, this break is going to break essentially, or break free from this code block, and the control is transferred outside this switch statement code body. So let's try to run this code here. So yes, compile, enter the test score. Let's say if I press 82, it says your grade is B, and then it says, then it encounters a break. The whole block is, the control is transferred outside this block, and the C out is goodbye is here. Now if I run this code again and I press 100, it says your grade is an A. So what would happen is 100 divided by 10 is 10. No statement here. It will run the very next C out, and then it will just break, because we have written break over here. Now what would happen, or let's take an example, another example. Let's say if I write 42. So if I write 42 over here, it says you're greater than F. So what would happen is that after 42 divided by 10 is 4 in integer terms, but there is no statement after this case 4. So it will find whatever is next to be executed, C out, and then find break. It will print this thing. So it's not necessary to print the statement list. You can just make a range over here if you want to. And if you remove the break statement, so let's see what would happen here. So here I have written the very same program. I've just copied it from 98765432110, and then I have removed the break over here. So these break, this is extremely important. This is very important to write the break statement over here, because the break statement breaks whatever the code block in which the program control is in. It breaks away from this whenever the break is encountered, it will just the control is transferred outside this code block. If I write instead of break, I write this thing, exit 0, that will just terminate the whole program. It will just run. In the previous scenario, it was actually printing the grade, appropriate grade, and it will saying goodbye. So if I run this code, let's create 92, it says your grade is an A. It did not print goodbye, because we were actually exiting the whole program with the return code of 0. We were saying return 0 instead of here. We are saying this return 0, exit and return 0. The program ended successfully. But when we are using break, it will the program control will go from the control this code block to outside of this code block. Coming to this code in which I've removed the break statement, what's going to happen is that the program was intended to have the same effect as the one which we did a few moments earlier, but there is no break statement. There are no break statements, so the program execution just falls through all the case statements it encounters. So let's first run this code. Enter test score. Let's say if I write, for example, 82, it just runs all the case statements, including the default as well. So it did not break over here. Reason is that after branching to case 8 and printing the grade is B or your grade is B, the program execution goes right to case 7, and then it prints your grade is C, and then no break statement encountered over here. Then it goes to this case 6, and it says your grade is T, and then it falls through all of these lines and it says C out, your grade is an F, and then no break statement. Then it also does the default that your score is out of range. So I mean, this break statement, since they were removed, the program execution keeps following through all the way down to the default statement or default clause, executing each of the cout statements along the way. So this is a logical error. We should always put the break after each case statements, so that the only that case and the relevant statements are run, and then we do not need to further check any other scenarios, because in going to this scenario, if this is true, or just write it here, if this condition is true, so we do not need to go all the way to all of these else statements and if statement. Let's take an example of making a simple calculator, which I have typed written before. It says a simple calculator which asks the user for the input, and it's asks the user for two inputs, actually two numbers, and then it's asks the user for the operator. So this is declared a variable character operator, and we cannot use the name operator for this variable because it's a reserved keyword in C++. Then we have declared two variables, and we ask the user enter two integers, and whatever the user has entered is assigned to n1 and n2. Then we say enter one of the following operators: plus, minus, multiply, divide, and remainder. And then whatever the user has entered as an operator, we take that letter and assign it to the character variable operator, or the OP for short. So this thing, I mean, we know that characters inside are numbers, so this thing is an integral number, obviously. So whatever the number, they mean, it's actually behind the scene is just matching the ASCII code. So it says that if case is this thing, if you are writing characters, you are going to match with this thing with this thing. So if this operator is equal to this plus sign, we are going to say cout n1 plus n2 equals to n1 plus n2, and then we write break. That's important. If the user has entered the minus sign, then it goes to here, cout minus here, and whatever the statement, that n1 minus n2 and then endl. Then if he or she has entered multiply or divide, then the relevant case statements are run, and after that break statements are also included. They are necessary, because if you don't do that, all of these statement, if I do not have these break statement and this break statement and this break statement, then after running this statement, it will run this statement as well as this statement. I did not write the default case, default clause, which is actually optional. We do not need to write the default case. So let's try run this code. So enter two numbers. If I press 2 and 3, and if plus operator, it says 2 plus 3 equals to 5, and that's it. If I just do it again here, 2, 3, and minus, the default clause here is actually optional, which I've explained that it only runs when all of these cases were, if these conditions were not proven to be true, or were tested, or they were not proven to be true. Actually, sorry, I'm talking about these cases. So if I want to write a range of numbers, for example, I'm going to come back to how to improve this calculator program, just to run it perpetually. So I'm going to go first to, if you want to select a range of numbers, once again, range of numbers, since this feature is not a standard C or C++ feature, it's a GNU compiler, C compiler feature. So if I say enter your test score, and then let's take the input from the user CNN and assign it to score, then if I write 90 triple dots and then 100 and then colon, sorry, I did not explain that earlier. I mean, you need to write colons after these case over here. So whatever case, you need to write these colons. It's not semicolon. Semicolon happens after this statement. So I write the range of numbers, and I say, yeah, if it lies between this range 90 to 100, your grade is an A, and if it lies in between this range, your grade is say so on, your grade is B, and so on and so forth. This, and default is the score is out of range. So if I run this code, if I say, for example, 77, it says your grade is C, and it runs okay. So you might want to check again and again if the code is okay. So I mean, the two things we need to consider here is that this value should be lower and this value should be higher, and there should not be overlapping cases. So if I write 80 and 89 and I write 89 over here, and I then again recompile this code, it says if I go to view and report window, it says duplicate or overlapping case. So obviously we cannot do that. There should be no overlapping numbers here. So, and one more thing is, instead of writing this thing, if I write 100 and I say 90 over here. It's an error actually. It might not check this error. Let's run this code. The score is 98. It says that the score is out of range, even though 90 lies within this range. So that's a runtime error, not a compile time error. So I need to write low and high in this order. But once again, need to emphasize, this is not a standard C or C++ feature. This thing is only available in the GNU C compiler. Coming back to the calculator program which we made using the switch statement, we can this program actually runs once only, because after running the required operation it just exits. So what I'm trying to do is is it possible to make the program run literally many times, so that the user can be asked to whether he wants to, or he or she wants to continue, and if that person says yes, then the program repeats itself. So what I've done over here, I'm going to explain that in lecture number 25 after midterm, that what is this while loop over here. This while loop, let me write the its syntax over here so that it's easy to understand. That if I write while, and if some condition, I'm just writing the, I'm not writing the actual code over here, that whatever I write over here, as long as this condition is true, the whole code will keep on running. So once it reaches the end of this code, it will go back again, it will check the condition, whether the condition is still true or not, and then it will just rerun the code itself. So this loop means going on around in circles. So this code will keep on running again and again as long as this condition is true. And obviously we do not want an infinite loop. So obviously within the loop we should have some kind of a if-else statement, or some kind of a check, or some kind of a condition to once we do not want the loop to run any further, we should make this condition false over here. So that's how this code works. So what I've done over here is that I've done actually two things. One is I have included all the code inside the while loop. So let me zoom out here. I'm going to explain that this while loop contains full code which was in the previous program. It also contains another while loop. This is for something else, because I'm going to check whether the user has entered the correct input or not. So I'm going to ignore that in a moment. So just ignore these two lines. What I'm saying is that the whole code is now enclosed within this while loop. We have the main function, and within the main function we have the while loop, and it, as long as this condition is true, we have declared a variable, character variable reply, and we have set the value to y, because we want the code to run the first time. Then y is equal to y, this condition is true, then this whole code will run, and in the end it will say that do you want to continue, press y or any other key to exit. Then if the user presses y, I will take the input and assign it to the variable reply, and then it will check again that if y is equal to y, obviously it is, so then it will run the code again, and say in the end it will say do you want to continue, press y or any other key to exit. So if I press any other key except y, maybe let's say n or u or whatever, so it will assign that whatever letter I have typed on the keyboard to the reply variable, and then it will check. Let's say I have typed n over here, so n equals to y, this condition becomes false, then this the control will transfer outside this loop over here, and then the program will terminate. So first run this code. I'm going to run this code here. It says enter two in numbers, so I just press 2 and 3. It says enter any one of the following operator. I just write plus, and it says 2 plus 3 equals to 5, and it says do you want to continue, press y or any other key to exit. So if I press y, it will say enter two numbers. It will just keep on repeating 8, and let's say the next number is, for example, 5, and enter any one of the following operator. Aside minus, it says 8 minus 5 equals to 3, and then it asks again press y, do you want to continue, press y. If I press y, again number, so if just press 10, and for example 87, and then I for example multiply these things, so it says 10 into 87, then you want to continue or not. So if I press any other key except y, just n or any other letter, so it will exit the program saying that process exited after so many seconds with the return value of 0, which was successful completion. Another thing which is here, I'm going to check whether the input is okay or not. So what I'm going to do here is that let me expand this. I'm asking the input for the numbers, and I'm asking the input for the operator. So I'm checking whether the user has entered the operators in this list or not. So if the user has entered some other character except for plus minus, I mean these are just characters here. So except for plus or minus or multiply or divide or remainder operator, user has pressed some other key. So I'm going to check whether that operator is not equal to this. Let's say the user has pressed for example letter y or letter t, for example. So t is not equal to plus, and t is not equal to minus, and t is not equal to multiply, and t is not equal to divide, and t is not equal to the remainder. So this condition will become true. The code will enter this block. Had it been false, I mean if the user has entered the plus sign, which was okay, so plus not equal to plus, that condition would have been false. It would short circuit because the all other operators are AND. So this condition is not true, and the code and the program control would not have entered this while loop. Now if the user has entered any other key except, like say, t, so this condition becomes true because t is not equal to any one of these characters. Then it will ask again, enter any one of the following operators, and then it will take the input and assign it to operator, and then it will check again. So and then as long as the user is not entering and the correct operator, it will just keep on asking for the correct operator. And as long as once the user has entered the correct operator in any one of these 5 operators, this condition will become false, and the code and the program control will transfer here, because it will exit the loop and the program control will transfer here, and this thing runs as we have explained before. So let's run this code. Enter two numbers, 2 and for example 5, and instead of writing or typing any one of these characters, I'm going to type for example t, which is not correct. It says enter any of the following operators, so I just write r and says no, and press I or anything no. So if I just press plus or the correct one of any one of these operators, then it will say 2 plus 5 equals to 7. Do you want to continue? And press 5 any other key to exit. So I'm going to write for example b and or n or whatever. So it will just exit the code or the program. So that's it for, oh yeah, there is one other topic we need to cover, which is the conditional operator. This conditional operator here is the ternary operator, because it requires like one condition and 2 expressions. It runs something like this. If this condition is true, the whole return of this thing, the return of this thing would be this expression, or if this condition is false, the return of this thing would be this expression. So let's take a look over here in this program. It says enter 2 numbers, and I take the input from the user m, and the next number is assigned to n. And if cout, if m is less than n, so if this condition is true, the whole return of this expression, I mean this expression, would be replaced by m. So and if the and this condition is false, the whole expression and the return value or the whole expression is replaced by n. So so it says if m is less than n, then it will just return m is the minimum. If m is not less than n, this condition is false, so it will just return this value and says that n is the minimum. So let's run this code. And let's say 2 and 3, and it says 2 is the minimum because 2 is assigned to m and 3 is assigned to n. 2 is less than 3, so this condition becomes true. So this value would be returned over here. I could also say I can also assign something like this, that integer a equals to this condition over here, this condition. So I don't need, no need for brackets actually, so I can just write something like this. Now what would happen if I cout and if I say a over here? So this a should contain the value of m if this condition is true, or a should contain the value of n if this condition is false. So let's run this code again. 2 numbers, 2 and 3, and it says 2 is the minimum, and this a has been assigned the value of m, which was the minimum of 2 numbers, and it was assigned to a, and we printed a over here. So this expression, I mean this what I'm talking about the return of this expression, that whenever we have this or conditional operator, it's actually going to return some value. That means if if you remember in the previous class, and if you write some conditions over here, this condition, if it's true, is going to return the value of 1 over here, and if that condition would have been false, it would have returned the value of 0 over here. Similarly, this conditional operator returns the value either this or this, depending on if this condition is true. This whole expression is going to be replaced by just m, or if had this condition been false, this whole expression would have been replaced by n. So just to summarize, in the end, we did the else if construct just to emphasize the parallel nature of the logic, and the switch statement is another convenient way to write the else if construct. And the syntax of switch statement is we have to write an expression which should yield an integral value, and these constants, I'm going to check whether this constant is equal to this thing or this thing, and you must write after a statement, you must write the break statement after each statement list for the each case. Otherwise you will have some kind of a erroneous fall through, which you should avoid at all costs. Then we wrote a simple calculator program with the switch statement. We made it run again and again using a simple while loop. I have not explained the while loop in detail. I'm going to explain it in lecture number 25, inshallah. But here it's just you can just use the very same code in all of the programs, because you do not need to run the whole code and press F10 again and again. The program execution will keep on repeating itself as long as the condition is true to repeat the loop. And the conditional operator, we saw that the ternary operator, and this condition, if it's true, this expression is going to be returned, or whatever number you have written over here. You can write the whole expressions for that. You can just write some addition subtractions over here, and if this condition is false, this expression is going to be evaluated, and the evaluated value is going to be returned.